Hey students, in this video I'm going to explain how to classify a triangle on the coordinate plane or in the coordinate plane. So when given 3 points on the coordinate plane, the triangle form can be described by measuring its sides and angles. To determine if the triangle is scalene, isosceles, or equilateral, you use a distance formula, which is right here, to determine the lengths for each side. You also could determine if the triangle is right triangle using the slope formula or the Pythagorean theorem. So we'll go over an example on that. If the triangle is not a right projector, it can be used to determine if it's obtuse or acute. Let's do 21. This is 3 points right here, JKL. And you need to imagine that this is a triangle and you're looking at the side lengths. One side length is created by the combination of point J and K. So we're going to write that right here. Another side length is calculated by the combination of K and L. So let's write that too. The other side length is combined from these two. So we're going to have JL. So these 3 segments are going to give you 3 measurements. To find the distance for each one, we're going to do the distance formula for each one, following this right here. And even though it says x2 minus x1, you could look at this as just as the difference of the x's squared, and then this could be plus the difference of the y's. Difference of y's. And then square that as well. And then doing the square root of all that. So let's set that up. We have difference of the x's, so we have -7 minus -9 squared, plus difference of the y's, we have -7 minus +1 squared. So if we type all that into the calculator together, we're going to have square root of -7 minus -9 squared plus -7 minus 1 squared. So that gives us 8.25, but if we round it. And then one thing I mentioned in class is that what if the answer is not given in decimal? What if the answer is given in square root? That means that you should type only the inside to find out what that number is. If I use what I already typed, I'm just going to press up, press enter, go back and delete that square root. And that results in the number 68. So what that means is that the inside of this square root is 68. And if I was to do the square root of 68, it gives me the decimal that we had initially gotten. So you need to be open-minded to understanding both answers, the one with the square root and the one as a decimal. All right, so let's try the next ones. We have difference of the x's for K and L. So that's -9 minus -1 squared plus the difference of the y's, 1 minus -1 squared. So then for that one, same thing, square root, -9 minus 1, or actually -1, squared plus the difference of the y's, 1 minus -1 squared. So that gives you also the same number we previously got. So that's just telling you that you have 2 side lengths that are exactly the same. We call those congruent sides. Let's double check if the third one is also the same to see if it's an equilateral triangle. So the last one is JL, so that we have -7 minus -1, and then the difference of the y's, -7 minus -1 as well. So let's type that here. -7 minus -1, and -7 minus -1. So that's 8.48, not the same. If we turn that into a number before the square root, we can see that it's not the same. So that was a 72. So the square root of 72. All right, so here we notice that these two sides are congruent. And therefore, we can conclude that this triangle is an isosceles triangle. So right here it says classify, we're going to put isosceles. And in class, we went ahead and practiced this one for sure, we did it in class. So let's do that one more time here in the video. We're going to do JK again, and then KL, and then JL. I'm just going to write all three and then we'll type them. Difference of the x's is -3 minus 2 squared, these two. And then the difference of the y's is these two, 2 minus 6 squared. The next one is KL. So the difference of the x's is 2 minus 8 squared. And then the difference of the y's, 6 minus -1 squared. Last one, JL, we have -3 minus 8 squared plus 2 minus -1 squared. All right, let's just go ahead and type these and see what we get. So -3 minus 2 plus 2 minus 6. And then square root of 2 minus 8 plus 6 minus -1. And square root of -3 minus 8 plus 2 minus -1. All right, so all three side lengths are different, which means they are not isosceles. This is a scalene triangle because they're all different. All right, we're gonna jump into this last one on this side of the page. This one is asking if you can verify if it's a right triangle. So we need to recall that when two lines cross at a 90-degree angle, these are called perpendicular lines. And in order to check in a grid, if two lines are perpendicular, you gotta compare the slopes. One of the slopes has to be positive, the other one has to be negative. So they have to be opposite. And then the flipped version of them. So opposite reciprocal. So let's check on that. Here, the one that looks like a 90-degree could be this corner right here. So we're gonna imagine that these lines extend and we're gonna check their slope. So this point to this point, it's rise over run, or rise all the way up here and then run over here. So the slope for this will be rise 3 and run 6. This simplifies to 1/2, which means you rise 1, run 2, rise 1, run 2, rise 1, run 2. So that's how this confirms that it's 1/2. For this other one right here going down, also by the way, this slope is for this one. So now let's do this one going down. This is the rise over run right here from this point to that. We're going to go down 2 and across 1. So we're going to have down 2 and across 1, which means we're going to have -2 over 1. And that simplifies to -2. So if you compare the slopes 1/2 and then -2 over 1, they definitely flipped, and then one's positive, one's negative. So yes, opposite reciprocals. And also what you could have done instead of rise over run is the slope formula from one point to another. But for now, we can agree that this is 90 degrees because of the slopes being opposite reciprocal. All right, so now besides that, just know that you might need to also check if this is a right triangle with Pythagorean theorem. So that's what this formula here is for. That means that if you have a triangle that's a right triangle, this right here is called a hypotenuse. And it's your C value. Then these are your legs. And this is your A value and B value. And these can interchange because they're just the legs. So the formula states that you're going to square A and B, add those values together, and they should equal C squared. So the thing is that we don't know the side lengths. So we will have to calculate the distances from each point to another using the distance formula like the one we did up here. Yes, it's a little bit of time consuming, but you don't always have to do it. It's based on what it's asking. So this is asking if it's a right triangle. We already proved that it is based on the slopes created with these lines. I'll show you the hypotenuse, the Pythagorean theorem with another example behind here. In the back of this paper, 10 and 11 are also more practice problems of just 3 points given to you, find the distance. Same thing here with this space is just asking you to find the 3 side lengths and classify the distance. The triangle. I want to jump into this last one, just the one we did in class as well. This is asking you use these 3 points to classify the triangle. Now, they're giving you a grid next to that, so you can always plot the points just to visualize what that triangle looks like. So 0, 0 is P, 2, 0 is Q, and then 1, 3, it's R. So just by looking at it, you could tell that this is symmetrical, and most likely these two are same side lengths. The bottom one, it's flat, so you can just count the distance right there, 1, 2, so this is 2 spaces right there. We don't know what these are, so that's where we will use the Pythagorean theorem to help us find the distance. We will just find if this creates like a little square right here, we will have this side squared, so 1 squared, and then this side square, 1, 2, 3, that's 3 squared. So it's 1 squared plus 3 squared, and it should equal your C squared. We don't know what C is, that's what we're finding. So 1 squared plus 3 squared, that's 1 plus 9, and then that's 10. 10 equals C squared. So to find the C, we will have to do the square root of that. So square root of 10, it's C. On a calculator, we just type square root of 10. It is 3.16. So this distance right here, it's 3.16. So picture this triangle right here. 2, 3.16. So now let's check the other one with Pythagorean theorem, and same thing, you're going to go this way to the left and then down. So to the left, it creates a 1 by 1 square again, so 1 square. And then going down, it's a 3, so 3 by 3 square. And it replicates the work we did over here, so that means that they are going to be the same answer as well. So that's finding the distances with the Pythagorean theorem. Just to confirm, we're going to do the distances with the distance formula. So PQ, QR, and PR. So PQ is 0 minus 2, x minus x squared plus 0 minus 0, y minus y. QR is 2 minus 1 squared plus 0 minus 3. So the y's. Next, we're going to do the x is a PR. PR is 0 minus 1 squared plus the y values 0 minus 3. And if we type all that, we should get the same answers we got doing the Pythagorean theorem on the grid. Alright, so that's the first one. That is my 2. And the second one is 2 minus 1 squared plus 0 minus 3 squared. So there's a 3.16 that we got here as well. And then, of course, the other one should also equal that. Make sure you put this in parentheses. Don't overlook the parentheses. All right, and the answer is the same. So yes, this confirms that this is 2, and this is 3.16, and this is 3.16. So we can agree that this is an isosceles triangle. All right, I hope this video helps you understand a little bit better how to do this. There's several examples that I went over. Let me know if you need more help.